Okay, it's a very interesting stream, I guess. So, on the count of three, I'm gonna go start it. Now, I'm gonna play my music now. Did I make it a bit loud? I think it's fine now. Okay. I'm fine. Um, okay, I think I know this. KL and then LM and K. She forgot KM. What? Yeah, 1 second, guys. I'm back with some coffee. Yeah,
Are you the kind of person who knows things? Things like you can get a domain from
I guess
Squarespace,
this
not
way.
just a website. Well, now you are that person.
I'm
Because now you
sorry that
definitely
was
know you can get a
my
domain from
dad.
Squarespace.
Um,
Something like whisperingbloom.com for your silent retreat. Or whisperingboom.com for your shouting
oh my,
retreat.
I can't. One
Whatever your
second.
dream, a Squarespace domain or website brings it to life.
It's a
All in
very
one
disruptive
place.
stream so
Get
far.
yours before it's gone with offer
There's a
code Make It
freaking
Rain for
ad.
10% off.
Um, I need some stream music. I don't know what Vinay was thinking about. Okay, so CAB is congruent to BDC. It says CBA is congruent to BCD. CBA. 38. already have trigonometry. Never mind, it's not trigonometry. It's just, never mind. It's just isosceles triangles. Excuse me. That was a weird question. Okay, so the 63 is here. Okay, 135. So 45 degrees. Yeah. Wow. What is this? Oh my goodness. Jeez. Just open all of them. C is F. C double prime is equal to F. This is so annoying. I'm gonna choose the longer answer. What? I never learned it like this. If C and F I don't know what the heck a transformation is. Wow, I guessed. I'm barely using my paper because it's just a lot of reading. A, B, C. A is D, B is E, and F is C. What? B prime. B. Okay. B is equal to E because same distance from D. Yeah. Yes, okay. A, D, B, E. They're just, bro. I don't know why it's like this. I don't like Khan Academy. I don't like this at all. You know, I'm gonna just rotation. Dilation. Dilation. I think if I take the quiz, stop texting me. Okay, I turned on Do Not Disturb. Negative 6-4. Kind of bored. Oh, use non-negative. Oh. I'm kind of bad at this. Let's just 1 unit to the right and 4 units up. 1, 2, 3, 4. I know how to do this. Rotate points. Okay. This is the one that's really bad. This might be my first time doing this, like rotating points, because I hate rotating points.
We're told that point P was rotated about the origin 0, 0 by 60 degrees. Which point is the image of P? Pause this video and see if you can figure that
Are you kidding me?
out. All right, now let's think about it. This is point P. It's being rotated around the origin. Like one meter of rotation is indicated.
So this is common sense. Watch. Wait, is it clockwise? Yeah, I think it's clockwise. Okay, whatever I said, never mind. The image of D. I want to see how you answer this. Why counterclockwise? Oh. Okay. Okay. C. I'm so bored. What? It's rigged. No. No. I gotta do it again. Never say something's common sense. B. What is wrong with this? C. Wait, how is it? I remember from last time. I think it's A. Okay, please. Clockwise. A. Yes. I don't want to do this. Ay. What the heck am I looking at? Okay. Okay. Oui, ça va? Oui, bonsoir. My dad walked in again. Okay, I don't know. I actually hate this. Wait, where is it? I think it's point M. so rigged. Ay, ay, ay. I'm gonna draw this. It's not really a speed run anymore, but perpendicular bisection. AA, BB. So it's kind of like this thing right here. So that's point R. What? Watch this point S. Low key, I don't care. I don't care. My mom walked in. Point S. ABC rotation point S. So AA means it's a bit more 115. I went backwards. Nice. This is so annoying. A, where's the other A? AA. So it's around like 30 degrees clockwise. Like, what? I'm doing that. Oh, I thought this was the original save. I'll just refresh. Okay, watch this. Number 30. 30. I'm gonna get another one wrong so I can restart. No, I don't want to. Now can I restart? Okay, nice. AA, so it's a bit less than 90 degrees, and it's upwards, so it's negative 75, right? C, AA, you rotate it like this way. Last one. Hey. Rotate that way. 45 degrees. That was easy.
If I rotate this by 90 degrees, it's going to be just like...
That looks like torture. If I rotate it 90 degrees, 90 degrees clockwise, no, not counterclockwise, just 90 degrees, it's 3, 4, negative 4, 3. And then isn't that 270? Y negative x, so y negative x. Negative 90 plus 360 is 270, and 270 is right here, so negative 37. Next, I don't want to tip over a rectangle. It's too hard. Easy, negative 5, 6. Or you can just memorize 270 like I did. Too much work. Negative 270 is 90. 90, look at the chart, negative. You swap, so y value is negative 6, no, x value is negative 6. So that to negative 68. Oh. What? Oh, okay, I get it. 720. 270, okay. Negative 270, so this is just 90. And 90 is 0. Nice. 90. Oh my goodness. Negative 4. Negative 4, negative 3. J 5, negative 6. Lastly, 2, 7. Please be right. Yay! This is just so annoying. Get this. Why am I doing? You know, just let me do my thing, you know. Oh, my timer paused. I just noticed. Or is it like not loading? Why is it? Oh, never mind. Okay, it's not paused. It's not paused. It was just glitching. Okay, it's not that bad. 6, -4. Ooh. 5, 6. There. Ooh, another easy one. Yes. -2. 6, -3. 2, -7. What? Oh my gosh. 5, -6. Yes. This is just 90 degrees, so 2, 3, 2, 3, -3, 2, 2, 7, 2, -7, 7, 2. Oh, that's not right. This is -3, 2, right? And this is 7, 2, and this is I -7, 7. What? Okay, I need to refer back to my chart. 2, 3, 2, -7, 7, -7. So it would be -3, 2, 7, 2, 7, 7. This is just another 90 degrees. So -3, 3. Okay. 5, -5. So 5, 5. 3, -3. -3, 3. Wait, what? No, 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 no. 3, 3. -3, 3. And L. -3, -7. So 7, -2. What? -3, -7. So 7, -3. I'm gonna go this out. 3, 3. 3, -3. 5, -5. -3, -7. So change these -3, -3, 3, 3, 5, 5, and 7, -3. -3, 3, 3, 3, 5, 5, 7, negative 3. Yes. AA, ready to rotate this way, it is clockwise. So it's more so 135. This is the same thing as 270. I'm just using the chart here because I'm too lazy to memorize it. I'll memorize it one day. 3, 2, 7, 3, 6, 7. So just swap the vertices. 3, negative 3, 4, 4. Okay. Two, negative 3, negative 3, 7, negative 3, negative 7, 7, negative 6. It's got rotated clockwise, and it's near 180, so it's 1, negative 150. Two, 4, negative 2, 4. 6, 7. Oh my gosh. Negative 6, negative 7. 2, negative 4. 3, negative 2, negative 3, negative 2. Negative 3, 2. And negative 2, 3. 2, negative 3. Please, I can't click farm now. Clockwise. Left, negative 3. Yes! Okay. Reflect points. Oh, I don't want to do this. Across the x-axis. Oh wait, this might not be bad.
We're asked to plot the image of point A under a reflection across the line L. So we have our line L B, and we're going to actually just click on a point right over there, and it would show up. But across the x-axis, essentially create its mirror image, it's going to be 5 units across the image. It doesn't hurt to do a quick visual diagram.
It does hurt. Across the y-axis is what I mean. You know, we learned this in 6th grade, but I'm too dumb to remember that. X-axis, so 4, negative 2.
Our C, negative 1, negative 2, and the negative of this.
No, I must say 1, 2, 3, 4, 5. I'm kind of slow at this. But slow and steady wins the race. One, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yay!
We're asked to draw the line of reflection that reflects triangle ABC, so that's this blue triangle, onto triangle A prime, B prime, C prime.
3, so 1.
Which is this solid in C down, above C prime and 3 below C. Let's see if this horizontal line works as a line. 1, that's looking
I think I understand it. Didn't I just get this question? Bro. Negative 2, 6, so 8. So 2, 2. Uh-oh. Let's just look. AA. So, just, yeah. Lastly, BB, I think I know what it is. That was very easy.
Whereas to use the reflection tool to define a reflection that will map line segment ME onto the other line segment below after the program. And the line of reflection, one way to think about it, we want to map point E. We want to map point E to this point right over here. We want to map point M, should be E, and this point should be equidistant from the line of reflection. Or another way of thinking about it, that line, -4, -4, and 2, blue color. So you see where it came from.
That's very annoying. Okay. So use midpoint formula. Let's just do a -2, 3, 2, 1. So it's 0, 2, and then B, -3, 6, 5, 2. This is 1, 4. 0, 2, 1, 4. I like how I can't see the coordinates. -1, 3, 1, 5, 0, 4. And then let's just use DC. DC. 0, -3, 7, 4. -3.5, -1.5, -1/2. Wait, no, 1/2. 3.5. So 7, 1. No, B, I'll just try a different point. -1, -1, 5, 5, 2, 2. Perfect. BB, 1, -1, 3, 3. So 2, 1. My camera kind of moving a lot. -2, -2, 2, -4. This is really boring. 0, 1. No, 1, negative 1, 0. What am I doing? Negative 1, 0. 3, negative 2, 1, negative 1, 0, 0, 0, negative 3. 1, negative 1. Very boring.
We're asked to plot the image of quadrilat so we can see the entire coordinate axis. We want to find the reflection across. So let's first reflect B prime, we could say, would be B per units.
Oh my.
Line segments IN, this is segment IN over here, and TO, this is TO here, are reflected over the line y is equal to negative x minus 2. So this is the line that they're reflected about, this dashed purple line, and it is indeed y equals negative x minus 2. This right over here is in slope-intercept form. The slope should be negative 1, and we see that the slope of this purple line is indeed negative 1. If x changes by a certain amount, y changes by the negative of that. If x changes by 1, y changes by negative 1 to get back to that line. If x changes by positive 2, y changes by negative 2 to get back
Oh
to
my, I know that.
line.
I know how that works.
And the y-intercept is if we want to reflect a given point. If we want to reflect a given point, say point I right over here, what we want to do is we want to drop a perpendicular. We want to find a line that's perpendicular, a line that has the point I on it, and it's perpendicular to this line right over here. Remember, this is the line.
Make it
This is the purple color.
bisected.
This is the line y is equal to negative x minus 2. Its slope is equal to negative 1. So I want a line that goes through I, point I, that is perpendicular to this line, and I want to drop it. I want to drop it to the line that the x direction I change in the y direction. We see that to go from this point to this point, and we get to this point right over here, which is the perpendicular needs to be equal to 1, which is however much I change in the x direction, I change in the y direction. We see that to go from this point to this point right over here, we decrease y by 4 and we decrease x by 4. Now, if we want to stay on this line to find the reflection, we just do the same thing. We could, to this point of intersection, we have to go down 1.5. We're going down 1.5, and we're going to the left 1. Image of I perpendicular. This line is going to have a slope of 1 because it's perpendicular to the line that has a slope of negative 1. And so to get there, we had to decrease our x long, so maybe this is 2 units long, so this is feeling good. And our change in y,
6, 7. Oh. Negative x. Up 5. Up 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. My brain's cooked. Okay. X-axis. -4, 4. So, -4. Y-axis. Please. Yeah. That was so, drinking water. ABCD. Okay. 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 3, 3, 1, 2. I'll just skip this. 4. Three. That looks about right, but I don't trust myself. -2, 6. So that 2, and then 5, 1, 6, 3. So it's this. Across the x-axis. 4, so -4. -6, 5. One more. I mean, 2 more. 1, 2, 3, 1, 2, 3. Okay. Violation. How long have I been streaming?
We're at. What we're going to do is just think this far down, highlighted with a scale factor of 3. Another example. so about the point A here, so it's actually below the fold. So let's see, there we go. That's our point A. We want to the dilation of, imagine a bunch of points here that represents some type of picture. And if you push them all 3 times further from point P, which you can view. So here we're told, plot the image of point A under a dilation about the, first of all, we don't, here we go, that's our point A. We want it to be about the origin, so about the point scale factor of 1/3, I should say. Origin. We now want to be in the same direction, but 1/3 as far. So one way to think about it, to go from the origin to A, you have to go 6 and B. So notice, as far, because under a origin.
Yeah. And 3, 4, 5, 6, 7, 8. Oh, this is so annoying. Oh. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so 4. 1, 2, 3, 4. And then, 4. Wait, and then 1, 2, 3. Please. Yes. Sometimes you just have to guess. Negative. Scale factor of 2, so negative 6, 4, right?
We are told that pentagon A prime, B prime, C prime, D prime, E prime, which is in red right over here, is the image of pentagon A, B, C, D, E under a dilation. So that's
It's 3. It's 3.
So for 1. So we are told that pentagon A corresponding side from A prime to B prime. Well, this length right over here is equal to 2. And so you can see okay, that was pretty, if you didn't between point right over A and our change in X B prime E prime is the image, and they haven't drawn that here, is the image of pentagon A, B, C, D, E under a dilation with a scale factor of 5/2. So they're giving us our scale factor. What is the length of segment A prime, segment A, that, but actually 2. What is the length of segment AB? Once again, they haven't drawn AB here. How do we figure it out? Well, it's going to be a similar way as the last example, but here they've given us the image and they didn't give us the original. So how do we figure out it is 8? So this.
Oh, there's so much water here. 1, 2, 3, 4. Speedrun is so slow. I don't care.
We are told that.
Chat. I know I'm talking to nobody, but I'm just losing it. Khan Academy is just so slow.
Triangle N prime is the image of triangle N under a dilation. So this is N prime in this red color, and then N is the original N is in this blue color. What is the center of factor? So we can figure out our 2. So one way to think about it is pick 2 corresponding points. So let's say we were to pick this point and this point. So the image, the corresponding point on N prime, is going to be the scale factor as far away from our center of dilation as the original point. So in this example, we know the scale factor is 2, so this is going to be twice as far from our center of dilation as the corresponding point. Well, you can immediately see, and it's going to be in the same direction. So actually, if you just draw a line connecting these two, there's actually only one, and it's changing that point, and then use the Pythagorean theorem to calculate the
Well,
length.
I don't care. B. Yippee.
The graph below contains the rectangle ABCP. Draw the image of ABCP under a dilation whose center is at P and a scale factor is 1 2/3. What are the lengths of the side AB and its image? So we're going to do a dilation centered at P. So if we're centering a dilation at P, the every point is going to be 1 2/3 times as far away from P. Well, P is 0 away from P, so P is still going to be, its image is still going to be at P. So let's put that point right over there. Now, point C is going to be 1 2/3 times far as it is right now. So let's see, right now it is 6 away. It's at -3, and P is, or its x coordinate is the same, but in the y direction, P is at 3, C is at -3, so it's 6 less. We want to be 1 2/3 times as far away. So what's 1 2/3 of 6? Well, 2/3 of 6 is 4, so it's going to be 6 plus 4 is going to be, you're going to be 10 away. So 3 minus 10, that gets us to -7, so that gets us right over there. Now point A, right now it is 3 more in the horizontal direction than point P's x coordinate. Which is another to the rectangle. And notice, point B, we're told, draw the image of triangle ABC under a dilation whose center is P and scale factor is 1/4. And what we see here is the widget on Khan Academy where we can do that. So we have this figure, this triangle, ABC, A, B, C, right over here. And what we want to do is dilate it. So that means scaling it up or down. And the center of that dilation is this point P. So one way to think about it is, let's think about the distance between point P and each of these points. And we want to scale it by 1/4. So the distance is going to be 1/4 of what it was before. So for example, this point right over here, if we just even look diagonally from P to A, we can see that we are crossing 1 square,
This is just so boring.
2 squares, 3 squares, 4 squares. So if we have a scale factor of 1/4, instead of crossing 4 squares diagonally, we would only cross 1 square diagonally. So I'll put the corresponding point to A right over there. Now what about for point C? It's not quite as obvious, But one way we could think about it is, we could think about how far are we going horizontally from P to C, and then how far do we go 5, 1, 2. We have a scale factor of 1, we would go up for point B.
1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4.
And we go from P to factor T scale.
Find the error.
We are told triangle A prime, B prime, C prime is the image of triangle ABC under a dilation whose center is P and scale factor is 3/4. Which figure correctly shows triangle A prime,
C.
0/4? We have, which we, so midpoint between, or the midpoint of segment AC, because now it looks like everything is 3/4 of the distance it was to that point. So they have this other center of dilation.
Okay. No. One, two, three, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Please. Thank you. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 1, 2. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3. 1, 2, 3, 4. 1, 2. Okay. Yes. Okay, it's easy now. I better not mess this up. Not that small, no. Oh no, I messed it up. I know how I messed up. Please, okay, it's easy. Come on. Come on. Come on. Come on. Yes. Okay, I think I'm fine. It's D. Like, I barely use my paper. When will it get good? One, 2, 3, 4, 5, 6. 1, 2, 3, 2. Alright. One, 2, 3, 4. So, 1 away. 3. E. Oh, unit test. Oh. Oh. Four. Cross the x-axis. One negative. 1 unit and 4 units. 1 unit to the right and 4 units at 1, 2, 3, 4. -4. What? I aced it. I aced it. Yes! I aced it. Oh, that was terrible. Reflections. What did I do?
We're asked to plot.
What? Anyways, I passed unit 1. Like, completely demolished it. And know, it's been a good stream, guys, and I'm tired of learning nothing. I like learned pretty much nothing from this stream, except for a few things. But yeah, bye guys.